Hello, good afternoon all. And today we will start the chapter number 4, that is the CPU scheduling and the algorithms. Okay, here we will see how we are going to schedule the different processes in the system and which are the different algorithms are used for the CPU scheduling. Then why the first question comes here as the why the scheduling is important, or why the operating system requires the CPU job scheduling. The first reason for the scheduling is nothing but the we are in today's days we are supporting the different concepts like a multitasking, multi-threading, and the multi-programming. When we are doing the multiple tasks at the same time, then there must be a maximum utilization of the CPU and IO we need to take, or we need to take care about all the maximum CPU utilization and the maximum IO utilization. For these two concepts, the scheduling of the processing is to be done. So what is the basic concept behind the scheduling is nothing but the we need to achieve the maximum resource utilization, that is nothing but the maximum CPU utilization and the maximum IO utilization. And when we are thinking about these two concepts, then we should think about how these all the processes are going to make it as a in the parallel we want to do all the processing, or how we are going to schedule these all the processes. So these things requires because of the scheduling we need to achieve the maximum CPU utilization and the maximum IO utilization. So in this slide you are going to see one diagram at the right hand side, okay, which consists the CPU burst and the IO burst. So every process consists of a CPU burst and the IO burst. So what is meaning of the CPU burst and what is the meaning of the IO burst? The CPU burst is nothing but the whenever every process requires the CPU for the execution and the input output devices for the execution. So the system mates one burst cycle is just like, first of all it gives the CPU to that process, and after that it will give the IO time for that process. So such like that, the first one the CPU is present is assigned to that process, then IO is assigned. Later one CPU is again assigned to process, then IO, and this sequence is going to be followed. And that is nothing but the one process cycle for the that process. And that one cycle which that exists, that is nothing but the CPU burst and the IO burst. So the CPU burst should followed by the IO burst, and the CPU burst distribution is main concern. Okay, here you can see when I want to complete one of the process, then first of all I will give it the CPU, then I will give the IO. If it remains processing is remains, if your process is not terminated or it is going to be completed in more time, then again we have to allocate the CPU, then IO, then CPU, then IO. So this is the concept behind the multi-programming, or simply we can say this is required when I want to do the scheduling. So these types of the cycles are assigned to that process. Then in the next diagram, that is nothing but the histogram of CPU burst times. Okay, in this diagram, this is nothing but the simple XY plot. On the X direction you are having the burst duration in the milliseconds, and on the on the y axis you are having the frequency. Okay, so what is the meaning of this diagram is nothing but simply you can say, you can see here, this is the line which indicates the every process is maximum number of processes is having the smaller burst time. Okay, and when the process is going to be complete, it is having the longer burst duration, means maximum number of processes are having the smaller burst duration. It accesses the CPU for smaller units, for the smaller milliseconds, and again it is going to be hand over to the IO and for the further processing. So we are going to move to the next slide, that is nothing but the CPU scheduler. Okay, we know that about the CPU schedulers. There are the two types of the schedulers are there. The first one is a short term scheduler and the second one is a long term scheduler. The short term scheduler selects from among the process in the ready queue and allocates the CPU to one of them. So that is the task for the short term scheduler, and the long term scheduler which moves your process to the ready queue. Okay, so that is the task for the long term scheduler. So there are the two types of the scheduler are present into the your system that we have seen into the chapter number 3 also. That is nothing but the short term scheduler and the long term scheduler. Then we will go to the next point, that is the CPU scheduling discussion may take place when a process switches from running to waiting state, switches from running to ready state, switches from waiting to ready, and it is going to be terminates. The scheduling is under 1 and 4 is nothing but the non-preemptive. Okay, so basically there are the two types of the processes in your system. So that is nothing but the preemptive and the second one is a non-preemptive. So what is the meaning of the preemptive and the non-preemptive? The preemptive processes that we can simply terminate it and we are going to place it into the ready queue. And non-preemptive is nothing but the those processes which are, okay, simply I will give the definition for the non-preemptive as to understand the definition for the non-preemptive scheduling, we have to understand the four situation. The first situation here it is mentioned, that is the switches from running to waiting state. So we know about the different states of the processes. The switches from running to waiting state. Okay, and the fourth one is the terminates, when one of the process is moved from the running to waiting state, and if it is going to be terminate, so that is nothing but the non-preemptive, means we cannot stop it. And when the switches running to ready state and waiting to ready state, so it is nothing but the preemptive. Okay, there are the four conditions in that the CPU scheduling decisions may take place for a process. So that is the first one, second one, third one, and fourth one. Okay, if the one and fourth happen, the process is become non-preemptive. If two and three happens, the process is become preemptive. Okay, so simply we can remember that the process in a running and ready state, if it is moved to the ready state, I will repeat it again. If the process which is in a running and waiting state, which move to the ready state, that becomes a primitive process. And the running process or is going to be in the waiting state or the terminate, it becomes a non-primitive. Okay, the non-primitive is nothing but the we cannot stop it, and where is primitive that we can stop this such kind of a processes. Then consider access to, why we are going to go for the primitive process, that is nothing but the consider access to the shared data, then preemption while it is in a kernel mode, and consider interrupts according during the crucial OS activities. Because of OS activities, it is going to be preempted. So this is the two different types of the processes, that is nothing but the non-preemptive and the preemptive. Simply we can remember these four situations, 1 2 3 4. 1 and 4 apply for the non-preemptive, and second and third we are going to apply it for the preemptive. The process that we can stop, that is nothing but the preemptive. The process that we cannot stop, that is nothing but the non-preemptive. Simply we can remember these four things, and 1 and 4 apply for the non-preemptive that we can stop, preemptive that we non-preemptive that we cannot stop, and preemptive that we can stop. So now we'll move to the next point, that is nothing but the dispatcher module. The dispatcher module gives control of CPU to the process selected by short term scheduler. Okay, means already one process is going in a running state or the in a waiting state, then again the scheduler has to give control to the CPU. That module is called as a dispatcher module. The task for the dispatcher module is nothing but the switching context switching is there, then switching to the user mode, then jumping to the proper location in the user program and restart the program. Means when we are going to, the short term scheduler is going to move your process into the ready state for the execution, then these all the things is going to be happen. And who is doing this all the thing? The dispatcher module is going to be going to do these all the things. So the name for this context switching is given, and that is done by using the dispatcher module. Then what is meant by the dispatcher latency? The time it takes for dispatcher to stop one process and start another process. Means we are going to stop one process, then load all the context related data of that process, and then we are going to start it. So the time required for these all the processes is nothing but the dispatch latency. So you need to remember the definition for this one, so it may be asked into your question papers. Then what is the scheduling criterion? So these are the three to five concepts. These are important to remember, because these all the definition can be asked into your paper also. The first one is a CPU utilization. So why the CPU utilization? Why we are going for the scheduling? We need to achieve the CPU utilization. We need to keep your CPU as busy as possible. And in the real system, the survey is taken, and you can simply say it, the CPU utilization falls in range of 40% to 90%. 40% is mainly for lightly loaded system, and 90% is heavily loaded system. Means what type of the percentage we can achieve for the CPU utilization in lightly loaded system? Means there are the some lightly processes going to be executed, then we can achieve the 40% of your CPU utilization, and in heavily loaded system up to the 90% of utilization we can achieve. Then what is meant by the throughput? The throughput is nothing but the number of processes that complete their execution per time unit. So suppose when we are taking the 1 microsecond as a your time unit, then how we are going to calculate the throughput in 1 microseconds? How many processes is going to be complete? If there are the 10 number of processes going to be complete into 1 microsecond, so simply we can say the throughput of your system is nothing but the 10. So this is the very simple thing how we are going to what is meaning of the throughput. That is the number of process that going to be complete in the execution per time unit. Okay, you can simply you can take as a 1 second also. Then what is meant by the turnaround time? The turnaround time is nothing but the amount of time to execute a particular process. Okay, so when the process is going to be admitted in your system, and after that it is going to be complete in your system, considering the all the condition, it should be in a wait state for some time, then later it is going to be in other mode, then again it is going to into the ready queue, then again is going to be in a executing mode. So these all the conditions, suppose for example at the 3:55 p.m. your process is going to be admitted in your system, and at the 3:40 p.m. your process is going to be completed, then this 5 minutes of time is generally called as a turnaround time. Okay, so this is the simple example for the turnaround time. So next one as a waiting time, the amount of time a process has been waiting in the ready queue. Means suppose one of the process is going to be put into the short term scheduler is going to be select your process in ready queue. It is going to be in a ready queue with all the resources, then up to how much time? it is in a ready queue, that is nothing but the waiting time. So this is the definition for the waiting time, that is the amount of time a process has been in a waiting in the ready queue. So that is nothing but the waiting time. So next one as a response time. The definition for the response time is nothing but the amount of time it takes from when a request was submitted until the first response is produced, and they have given as not output. Okay, why we are going to say here what is the difference between the turnaround time and response time? We are getting the first response produced. Means if we consider the your time sharing system for some amount of a time, that process is going to be executed. First of all, for the 2 microseconds it is going to be executed, then again P1 is executed for the 2 microseconds, then P2 comes, it is again executed for the 2 microseconds, then again P1 comes. What is meant by the turnaround time? The total time calculation. And what is meant by the response time? The first response you will get, that is nothing but the response time. Means P1 comes in the execution, after the 2 microsecond it sends the first response, then what is nothing but the response time? That is nothing but the 2 microseconds. And up to the 10 microsecond it is going to be complete the your whole process. What is the then your 10 microseconds is a your turnaround time, it is not a response time. So that is the difference between the response time and the turnaround time. So these all the definitions you have to remember, these are the very important definitions for the understanding of the all the algorithms that we have to see. Then the scheduling algorithm optimization criteria. So then what we have to achieve? Okay, we have seen these all 5 criteria, and in what manner the scheduling has to be done. The first one, that we have to achieve the maximum CPU utilization, we need to achieve the maximum throughput. Okay, so these two things we have to achieve it as a maximum, and then we require the minimum turnaround time, means at the minimum time your process has to be complete. Then minimum waiting time, also for each and every process we have to keep minimum waiting time, and also the minimum response time. So you need to remember these 5 optimization criteria: maximum CPU utilization and the throughput, minimum turnaround time, waiting time, and the response time. So we will go for the your first scheduling algorithm, that is nothing but the first come first serve. That is the simple algorithm, the FCFS scheduling. Here you can see the process P1, P2, P3 is given, and the burst time. Burst time means P1 requires 24 simply we can say microseconds to complete, P2 requires the 3 microseconds to complete, and P3 requires the again 3 microseconds to complete. Suppose the process arrive in the order is nothing but the P1, P2 and P3. Okay, then the Gantt chart for the scheduling is nothing but the such like this one. Okay, the at the 0th second, because P1 comes first, at the 0th second P1 is going to be executed. Okay, what is the algorithm here? First come and the first served. We are not going to preempt any process here. This is nothing but the non-preemptive algorithm. We are not going to stop any one of the process until its completion. So that is nothing but the non-preemptive algorithm. And what is meant by the preemptive algorithm? In between we can stop. Okay, so the first of all the P1 comes here, and for the how many time it is going to be executed? For the 24 microseconds. Again the P2 comes, P2 now load at the 24 second, and up to 24 plus 3 up to 27 second it is going to be completed. Then again P3 comes, then again it is going to be up to 30 microsecond it is going to be executed. So this is nothing but the Gantt chart for your FCFS scheduling algorithm. So we need to calculate here as a waiting time for P1. P2, P3 and average waiting time for the processes. So the waiting time for the P1 is nothing but the 0. Why this is 0? Because of this is the first process to execute. Okay, then waiting time for the P1 is generally it is a when the P2 starts after the completion of the P1 and P1 takes 24 microseconds. So the P2 waiting time is nothing but the 24, and then what is the P3 waiting time is nothing but the 27 because it starts at the 27. Okay, so we have calculated the waiting time for the P1, P2, P3. So the average, now simply we can calculate the average waiting time as 0 plus 24 plus 27 divided by 3, that is nothing but the 17. So the 17 is the average waiting time for FCPS algorithm. Okay, and when it comes into the such kind of a order. So this is nothing but the how we are going to calculate the waiting time for the processes and the average waiting time for the processes. Okay, so now we will see the another condition here. Suppose that the process arrives in the order such like P2, P3 and P1. Okay, then now again you can plot the Gantt chart here. That is nothing but the P2, P3 and P1. P1 executor started at the 3, then again P3 starts at the 3, P2 starts at the 0, P3 starts at the 3, then P1 starts at the 6. So waiting time for the P1 waiting time is as a 6, P2 waiting time is a 0, P3 waiting time is a 3. Okay, and average waiting time you can see here 6 plus 0 plus 3 divided by 3 is nothing but the 3. Okay, so it is a much better than the previous case. Okay, when we are comparing here, the waiting time here as a 27 and the average waiting time is a 17. But in the second condition you can see the waiting time for the each process is a 3 and the average waiting time is also 3. So it is a much better than the previous case. Okay, and such type of effect. So now simply we can say we can achieve the maximum efficiency or the maximum utilization by short processes behind the long process. So that is nothing but the convoy effect. Okay, or the another condition we can take into consider one CPU bind and one many IO bound processes. So that will helps for the good efficiency or the good output. So again we will take one example and we will see. Okay, we will take the empty notebook here, the first one as the process. So be ready with your pen and book. You need to calculate the average waiting time and waiting time for the processes. Okay, here the P1 is there. Total number of processes are the 4: P1, P2, P3 and P4. Okay, and burst time require 8, 4, 9 and 5. Okay, and it comes sequentially, means order of coming is nothing but the P1, P2, P3 and P4. Okay, then now quickly tell me the waiting time for each processes and the average waiting time. Okay, Swapnali, Swahili, Priyanka, quickly calculate the average waiting time for each process. Waiting time for each process and average waiting time. Okay, I will give you 2 minutes.
Sir, waiting time 26 and average waiting 4.5.
Waiting time.
26.
Okay, tell me waiting time by process. For P1, waiting time is, P2 waiting time is,
P1 waiting time is 8, P2 waiting time is 4,
yes, no,
P3 waiting time is 9, and P4 waiting time is 5.
okay, Swapnali,
P1 waiting time is 4, P2 5, P3 8 आणि P4 9.
not it, Priyanka, P1 waiting time,
Sir,
hmm?
P1 0,
Yes, okay, P1 0, then P2,
P2 4,
P2, how it is 4,
Sir, 8.
P2 is 8, okay,
8,
P3,
4.
4,
4.
P3,
P4 is 9.
Is 9.
P3 is 12 because P3 is 12 because 8 plus 4, after 8 plus 4 the P3 is going to be start. So the P3 waiting time is 12 and the P4 waiting time is 8 plus 4 plus 6 plus 9, that is nothing but the 21. So this is the waiting time for the uh, your all the processes. So obviously the confusion is going to be happen. So it is better to draw the Gantt chart. So for this purpose we have to draw the Gantt chart, and how we are going to draw the Gantt chart I will show you again. Okay, the small box you have to plot it here. Okay, then how many processes going to become, that you told, now you are having the 4 processes, so simply you can draw the 4 things. Okay, so for this comes into the sequentially, means first of all the P1 is going to become, okay, the P1 is going to become, then P2 is going to become, then P3, and then P4. Okay, so this is nothing but the Gantt chart, and always you have to, when you are going to calculate the waiting time and average waiting time, then you should plot this Gantt chart. And so the first of all, your P1 starts at the 0 because no process is in a no process is running, so it is simply starts at the 0. Then the units required for the P1 to complete is nothing but the 8. So after 8 the P2 is going to be start. Okay, then the P3 is going to be start, and P2 requires the 4 microseconds. So that is nothing but the 8 plus 4, so that is nothing but the 12. Okay, and later the P3 requires the 9 units to complete, so simply we can take here as a 21, and after P4 requires 5 to complete, so we can simply put it here as a 26. So this is nothing but the Gantt chart, and by using the Gantt chart you can calculate your waiting time and average waiting time. So I will write down here for your understanding. P1 requires 8 microseconds to complete, P2 requires 4 microseconds to complete. Okay, then P3 requires 9 microseconds to complete, and P4 requires, okay, 5 microseconds to complete. Okay, now you can understand here that the P1 comes first, so directly we can start it. So P1 takes the waiting time as a 0. Then P2 comes, but already P1 is going to be executed, so it requires them 8 microseconds, so P1 starts at the 8. Okay, so when we are calculating the average waiting time, so simply we can take the 0 plus 8 plus 12 plus 21. Okay, and we need to take the, sorry, we need to take the average divided by how many processes are there? 4 processes. So we need to divide it by the 4. So anyone can tell me answer? Okay, what is the answer? Quickly, anyone can do the calculation and tell me the answer.
10.25.
10.25. Good. So that is microseconds is nothing but your average waiting time. Average waiting time. Okay, this is your average waiting time. Okay, and waiting time for P1. Can anyone tell me P1? Swapnali.
0.
Okay, P2
8.
8, P3
12.
okay 12, P4
21.
yes, good. So now we can understand that if we are considering the any example, just like we are having the 4 processes P1, P2, P3, P4, it comes sequentially. That is nothing but the P1, P2, P3, P4. It is going to be execute, and what we are going to understood here, that is nothing but the FCFS, first come first serve. What is the algorithm? First come first serve. So we are not, it is a non-preemptive algorithms. In between we are not going to stop any process. So that is nothing but the first come first serve. It is non-preemptive algorithms. And how we are going to calculate the waiting time and average waiting time, that is nothing but the, first of all, draw the Gantt chart, then calculate the waiting time, and simply divide that all the waiting times by your number of processes. So simply we will get the average waiting time. Hopefully all of you are understood this concept, that is the waiting time and average waiting time, and this algorithm. So that is nothing but the first come first serve. So simply we can also say that is for the, it is a FIFO, FIFO, first in and the first out. Okay, simply that uh, method also we can say here it is going to be executed. So for today we will stop it here, and if you have any kind of a doubt, so you go ahead, you can ask. Thank you.